Hi everybody, today we're going to have a quick look at the solution to task 1, which is a near future nuclear disaster scenario. So a group of people have created a sensor-based alarm system, and the alarm system uses 3 sensors: the motion sensor, the gas sensor, and the pressure sensor. Now, if there's nobody outside, the motion sensor is just going to send the equivalent of binary zeros. Just continuously sends that data: 0, 0, 0, 0, 0, 0. And suddenly, if somebody is outside, the sensor will detect that and start to send ones. 1, 1, 1, 1. It kind of alerting there's a change of state there. So now somebody is outside. The gas sensor, if everything is fine, is just going to send ones. 1, 1, 1. 1 into the system. But as soon as the oxygen levels are low, the gas sensor detects that and it starts to send the equivalent of binary zeros into the system. And the pressure sensor, as long as the escape vehicle is in the correct place, the pressure sensor will continue to send ones into the system. 1, 1, 1, 1. And as soon as someone moves the escape vehicle, it's in the wrong place now, the pressure sensor will stop sending ones and start sending zeros. So we can use Boolean logic in a digital circuit to create a scenario where a red light is automatically switched on if these conditions are true. There is someone outside, or the escape vehicle is not in the correct place, so one of those has to be true, and the oxygen levels are low. Now we know that with AND logic, both inputs to an AND gate have to be 1. Right? That's AND logic. This has to be 1, and all of this has to become 1. So we can say that if the oxygen levels are low, well, that has to be 1 to activate the AND gate. We've got a problem here because the oxygen levels are low, the gas sensor is giving us zeros. But no, to activate that AND gate, we need ones. So we're going to have to find a way to reverse the input for oxygen levels in order for the circuit to work. And we'll have a look at how to do that in a moment. Equally, this OR gate is activated if at least one of these inputs is 1. So if this is 1, the OR gate will be activated. The output will be 1. Or if this is 1, the OR gate will output a 1. It will be activated, okay? So this is also a problem because the escape vehicle is not in the correct place. We get a 0 from the pressure sensor. But we need that to be a 1 because we're trying to activate this OR gate. So let's have a look at how to do this. Let's look at the logic for this top line of the logic here. There is somebody outside, so that's the motion sensor giving us 1s. Or the escape vehicle is not in the correct place. That's the pressure sensor giving us zeros. And we're using an OR gate to do this. So let's go back to Circuitverse. We're going to grab our OR gate. There is somebody outside. So that's when the motion sensor is sending us 1s. Or the pressure sensor is sending zeros. Now to activate that OR gate, we need this to give us 1s. So we're going to use a NOT gate to transform the input to be a 1 or the 1 to be a 0, and that should work. Now just to see if it does work, I'm going to do this. I'm just going to get away from the problem for a minute. What? It's on. Why is it on? Both inputs are 0. Well, it's on because the pressure sensor is sending zeros into the system. This means that the escape vehicle is in the wrong place. The escape vehicle is not in the correct place. We need to activate this OR gate because the escape vehicle is not in the correct place. The pressure sensor is giving us zeros. All we have to do is turn those into ones, and we can activate this, which will activate the lamp. Do you see how that works? If we say that the escape vehicle is in the correct place, it's in the correct place, and there's nobody outside, that's fine. We don't need to turn the alarm on. So that's how that works. So let's get rid of these lines, and we'll look at the next piece of logic, which is this piece of logic. The oxygen levels are low. Whoops. The oxygen levels are low. Well, that's also giving us a 0. But we want to activate a gate. Which gate? We already have 2 inputs there. Oh yeah, this gate, the AND gate. This AND gate is going to take the output of this circuit as one input and the output of this as the other input. Okay? So let's go and get an AND gate. And the output of this circuit that we've already drawn is going to be one of the inputs. And the other input is from the gas sensor. But remember, the gas sensor, when it's 0, the oxygen level is low. We want to activate the AND gate. So we're going to have to reverse or invert that. Now let's connect that up to the lamp. Okay. It's not switched on. Why isn't it switched on? Well, there's nobody outside, and the vehicle, the escape vehicle, is in the correct place. So there's no reason to activate that OR gate. Now this gas, the gas levels are low. Gas levels are low, that's a problem. So we've got 1 coming into the AND gate, and we've got 0 coming into the AND gate. 1 and 0 is 0. So we're not going to turn on the alarm. Now let's say the escape vehicle is in the wrong place. The escape vehicle is in the wrong place. Here we have a 1 from this point. This is 1. 1 or anything is 1. So this output here is 1. So we have a 1 going into the AND gate. Gas levels are low. That's a problem. We have a 1 going into the AND gate. 1 and 1. The output is the alarm is on. And that's a solution to task 1.